I'm Todd Mostek, founder and CEO of MapD. Over the next 7 minutes, I'm going to do my best to show you how to extract potentially tradable insights from a 1.2 billion row public New York City taxi data set, which we joined to a proprietary data set from Factual of every business in the greater New York City area. You don't often see public demos of this size, and it's probably because CPU systems simply aren't able to crunch this size of data interactively in real time. They might eventually give you the answer you need, but it's going to take a lot of time. It's probably going to need a lot of servers, costing you both time and money. At MapD, we take a different approach. We literally built a system from the ground up to leverage the massive parallelism of graphics processing units to run SQL queries over multi-billion row data sets in milliseconds. And optionally, we can actually take the results and use the graphics pipeline of the GPUs and render or visualize the results. So GPUs, which started as accelerators for video games, have now emerged as a game-changing paradigm shift in the compute space. They're literally powering most of the top supercomputers, as well as driving innovation in the machine learning space, particularly in deep learning. GPUs literally allow you to do more with less. Case in point, in this demo I'm about to show you, we're running this not on a cluster, but a single server with 8 Nvidia GPUs. So before I begin, I want to give a few caveats here. First is that I'm a computer scientist and not a hedge fund manager. And second, that the data you're about to see, it's very rich, but there's a lot of confounding variables which go beyond the scope of the next 5 minutes to dive into. So without further ado, let's take a look at the data. So here we can see the data in all its granular beauty. This is 1.2 billion rides. New York City, we're specifically focused on Brooklyn and Queens. You can see JFK Airport here. In MapD, we don't pre-aggregate, pre-can, or pre-index anything. You're looking at the data at the granular level. Because we have all this brute force power, this supercomputing power out of these GPUs, I can literally hover over any point and get the details associated. So let's zoom into JFK. And so now we're looking at drop-offs, taxi drop-offs to JFK. Here they're colored by the pickup borough, Manhattan, Queens, Brooklyn. We have a histogram of trip distance. We can see that over time there's a gradual increase in drop-offs to JFK. What if we wanted to look at another facet of the data? For example, whether people are paying cash or credit card. It's very easy in MapD to add this kind of stuff. So I'm going to look at payment type. I'm going to do number of records. And so we have a table. I'm going to turn that into a bar chart. And then, so now I can filter on this. I can say, OK, there's an increase in credit usage over time. There's a decrease in cash usage. Let's move to another view of the data. I'm going to show you another kind of fun insight. We're going to zoom here into the Lower East Side. Here we can see this time histogram of the data. You can see that the peak ride density is on Friday and Saturday night. So that makes sense. There's a lot of bars and nightclubs in this area. If we actually got very granular on the data here, we could even see kind of the weekly cadence where you have Friday and Saturday where people are going out to the bars. But our goal here was to extract potentially tradable insights, right? So on the right here, you actually see this data, which we joined from Factual, as I previously mentioned. This is where the taxi rides are being dropped off. So if I zoom out a little bit and I click on Starbucks, we can see all the rides, 42 million out of the 1.2 billion, that are being dropped off near Starbucks. And we could normalize this so that we're comparing the rides to the greater kind of ride population and seeing what's different about them. Here we see that Starbucks rides tend to be dropped off in the morning. So it does seem like there's a signal here. You might say, hey, well, how do we know that they're going to Starbucks? I would argue that if you look at the data here, you'll see that things make sense. People tend to be dropped off at Citibank during business hours, Citibank ATM, Friday and Saturday nights, probably going out to bars. And you can even look at Redbox. So a lot of Redbox locations, and it's Friday night and the weekends, basically. So let's go back to Starbucks. You're going to notice a few things. First off, down here, we have basically a histogram of the median household income of the pickup census tracts that the rides are coming from. So here you can see that Starbucks maybe skews kind of towards the low end of the data. there might be a gradual decline in ride density over time. That could be interesting to investigate in conjunction with their stock price. I could also look at Gap, for example. We see another drop-off that actually kind of correlates to their stock price. Here we see that maybe there's more purchasing power for Gap customers. They're actually coming from higher income census blocks. So I'm going to actually look for something else, which I found interesting. So Hyatt, it looks like there's 6 Hyatts in Manhattan. And one of the interesting things here is you're going to notice this pretty steep increase in taxi drop-offs around 2013. And if we actually looked at the stock price for Hyatt over the last 5 years, you see something similar. There's a correlation here. Again, I'm not a hedge fund manager or a statistician, so this would require further investigation. So to do that, actually, the great thing that MapD ultimately is a SQL database, a really, really fast SQL database. So you can, oops, here. I wasn't connected to the data here. But essentially, you would get all this data. I ran this query. You get all the data. You could pull it into R. So I'd like to say, before I end here, that if you follow us on Twitter, we haven't made this data set public, but we'd love for you guys to play with it. So if you follow us on Twitter and send us a private message, we'd be happy to give you early access to this data set to play around. We're being used quite heavily among hedge funds in Wall Street. People finding that queries that took them minutes or hours now take them milliseconds, and they can slice and dice the data incredibly interactively and in real time, getting trading insights faster. Of course, it doesn't have to be just hedge funds. There's also plenty of use cases in customer service, customer segmentation, and fraud detection. Thank you.